Hi, welcome to our hands-on segment of the lecture, and today we're going to work with an elastic load balancer. And let me describe the sort of architecture we're going to build. What we will do is we'll launch two EC2 instances which are running or using a special AMI that I've created, and it's a publicly available AMI. This AMI includes an Apache web server and a very basic PHP-based application, which does something very simple. All it does is when you access the web server, it will respond back with the EC2 instance ID associated with the instance that the web server is running on. So we'll have two web servers. We'll create an elastic load balancer, which we can use to distribute requests across both web servers. And I'll show you that the web server is able to determine when an EC2 instance fails, and it's able to reroute requests to the healthy web server appropriately. Let's start out by creating the two EC2 instances. I've already logged into AWS. I'm in the EC2 dashboard, and I will click on the Launch Instance button. The first thing I need to do is select an AMI, and I will specify the AMI that is in the presentation. I'll search for that. That's going to be a community AMI. Again, it's publicly available. It's called Web Server Failover. I will select that AMI. Next, I need to select an instance type, and I'll just use the T2 micro instance type. Click Next to configure details. I want to create two instances. I can do that. I can create both of them at the same time. And I'm going to use all of the default settings here. And click Next, Add Storage. That looks fine. I'll click Next, Add Tags. And I'm going to add a name tag and call it Web Server. And you'll see that this particular tag will actually allow me to specify the name that appears in the EC2 instance dashboard, the name that's associated with the instance. Click Next, Configure Security Group, and I'm going to create a new security group, and I'll just call it, I'll call this one Web Server -ELB. And this is for my ELB hands-on project. I don't need to SSH into these servers, so I'm going to remove that default rule. You could leave it there if you wanted to. I do need to add a rule allowing HTTP traffic in from port 80 from everywhere, 0.0.0.0/0. Click on the Review and Launch button. And I will go ahead and launch these instances, specify an existing key pair, launch instances. And at this point, I'll pause the video just to wait for those instances to launch. Okay, my two EC2 instances are now running. Each of these EC2 instances has a public address, and let me select the first one. I'll copy this public IP, and I'll open up a web browser tab, and I'll browse to that IP address. And you can see that the web server is now responding, and it's responding with this little message that says, "Hi, I'm instance," and then an instance ID. That ID is the EC2 instance ID for the server that the web server is running on. This is an easy way for us to distinguish which server is responding to a web request. If I were to access the other web server, then it would respond back with its own instance ID. Okay. I will close that tab. We have our 2 web servers up and running and responsive. And the next thing I want to do is I want to create an elastic load balancer. I will go down in the EC2 dashboard to the load balancers menu, select load balancers, and I'm going to create a new load balancer. And here you see that the console presents us with 3 different load balancer types. I mentioned this in the lecture. Primarily, we'll use the application load balancer in this course. The application load balancer is designed to load balance web application traffic. The network load balancer can be used to load balance any type of traffic. And then, of course, there's the sort of older classic load balancers. So going forward, you'll principally use the application load balancer, but if you wanted to load balance some other type of traffic, then the network load balancer would be a great option. I'll click on the application load balancer, and I can begin to specify the settings for my load balancer. I will call my load balancer the web server -ELB. This is going to be an internet-facing load balancer. If you recall from the lecture, I mentioned that load balancers can be both public-facing or internet-facing, and they could also be internally facing. If you wanted to load balance the communications between 2 internal services in your platform, then you would specify an internal load balancer. I need to configure a listener for the load balancer. The listener specifies what type of protocol and port the load balancer will listen for communications on. And by default, the load balancer is listening on port 80 using the HTTP protocol, which is exactly what we want for this hands-on exercise. And so I don't need to add or modify this listener. We need to specify the availability zones that the load balancer will utilize. I've created this load balancer in the EC2 instances in the North Virginia region, and that region has 6 availability zones. If I had created my EC2 instances in specific availability zones, then I could just enable those specific AZs in the load balancer configuration, but I don't even know which AZs my EC2 instances are running in. I didn't really specify that. And so what I will do here is I'll simply enable all of the AZs. I'll click Next, Configure Security Settings. And it's just popping up with a message saying that, hey, you don't have a secure listener enabled, which in this case is fine. I don't have an SSL TLS certificate. I'm not supporting SSL communications in this exercise. And so we don't need to configure a secure listener. Click on Next, Configure Security Groups. And here I'm just going to select the security group that I had created earlier called web server-ELB. I'll make sure the default one security group isn't enabled. So the the ELB and the web servers will use the same security group in this exercise. Next, I need to create a target group. I've provided the ELB with some basic settings. I have specified the listener. So the load balancer is going to listen for traffic on a particular port and protocol. Now I need to specify where the load balancer is going to forward that traffic to. And it's going to forward that traffic to a target group. I'll give that target group a name. I'll just call it web servers. The target type is going to be an EC2 instance, and it's going to forward it using HTTP on port 80. Next, I need to configure a health check. The load balancer can perform a periodic health check to understand the health of the EC2 instances in its target group. And it does that by essentially making a web request to members of the target group. So it's going to use HTTP, and it's going to make a web request to a particular path or to a particular endpoint. In this case, I'm going to use /index.php. How do you know what this path should be? Well, it's going to be completely dependent on your application. This path is something that you create, that you specify when you are building your web application. And if you are a web developer, you know the index.php generally represents like the index page or main page for the web application. Oftentimes, if I'm creating a web application, I will create a special endpoint path just for health checks. And then under the advanced health check settings, we can specify how the ELB is going to perform the health check. And in terms of like, and how that health check is going to determine whether an instance is healthy or not. The interval setting specifies how often the health check will occur. In this case, by default, the health check is going to occur every 30 seconds. Every 30 seconds, that ELB is going to make a web request to each of the web servers in my target group and to identify whether or not they are responsive. I'm going to change this interval down to 10 seconds for this exercise. Now, when it makes a web request, it's expecting that web server, the web server that's running on that EC2 instance, to respond within the timeout period, which is 5 seconds. If the web server doesn't respond within 5 seconds, then the load balancer will consider that health check to be a failure. Now, just because a health check has failed doesn't mean that the load balancer considers the EC2 instance to be unhealthy. The instance might be exhibiting some sort of intermittent failure, or maybe it's just like overloaded and it's just not able to process the request in time. In this configuration, by default, the server has to fail 2 consecutive health checks before it's actually considered unhealthy. And that's the unhealthy threshold, 2. Once the server is considered unhealthy, if it becomes responsive again, it has to pass 5 successive health checks in order to be considered healthy again by the load balancer. And when the server responds to a health check, it has to respond back with an HTTP code of 200, which is the standard OK success code that a web server responds with. Now, if you're sort of thinking about these numbers astutely, you might have noticed that there's kind of a potential issue here. Now, if the ELB makes a health check to an EC2 instance and the web server on that EC2 instance responds back okay, and then right after that health check is performed, that instance were to fail, then the load balancer would still see the EC2 instance as healthy, even though it's no longer responsive. The next health check that the ELB performs on that server, that health check would fail. But again, the load balancer has to see 2 consecutive failed health checks before it really considers that instance to be unhealthy. So using these numbers, I mean, it could be 50 to 60 seconds before the load balancer truly considers that EC2 instance to be unhealthy, and it removes it essentially from the pool of target servers. Up until that time, the ELB will continue trying to route requests to that unhealthy, or to that server which has failed, because it's, until it fails 2 consecutive health checks, it's not really unhealthy, even though it's not truly responding to requests yet. So what this really means is that while the elastic load balancer can fail over requests, it can't really do it instantly. Can't do it instantaneously. There's a period of time during which it could continue to send failed requests, or send requests to a server which has failed. And it's only after this period of time that we these thresholds and the timeout values and so on that we specify in our health checks, that it's only after that period of time that the server is really unhealthy. What this means for us as platform engineers and developers is that we need to design our platform. We need to design, especially our client applications, our consumer services, to be able to handle these sorts of failure modes. And later on in the course, I'll talk about some patterns that we can implement that will make our clients and services more resilient. Okay, so the bottom line with these numbers for the health check is these are something you need to tune for your own application and platform. There's no like default setting that makes sense in every scenario. Let's go ahead and click on the Registered Targets button. And if I scroll down here, you'll see that I have no registered targets currently. I have a couple instances which I can use as registered targets. So I will select those instances and click on the Add to Registered button. And now those instances are going to become registered targets. I will click on Next Review, and I can review my settings, and then click on the Create button. And we'll go ahead and create my load balancer. In the load balancer dashboard, then I can see my load balancer has been created. I can click on the Listeners tab and see that I have a listener on port 80. If I click on monitoring, I can see like if there's traffic. Of course, I'm not sending any requests yet, but I could monitor some metrics associated with my load balancer if I wanted to. I'll go back to the description tab. And probably the most important attribute to note here is the DNS name. This is the endpoint address for the load balancer. And this is really important to note, because you will use this endpoint address to access the load balancer. And if you were using the load balancer in your application configuration, this is the endpoint address that you would use for the load balancer. The load balancer has a set of IP addresses, but you would never ever want to reference the load balancer via an IP address, because the IP addresses associated with the load balancer are subject to change. This is a managed service, and you have no control over what IP addresses are assigned or how long those addresses may assign. So you always want to reference the load balancer via its DNS name, via this endpoint. I'm going to go ahead and copy this address because I will use it here shortly. Now let's look at the target group that we have set up. I'm going to click on the target groups link, and I have my web servers target group here. And you can see that I have my targets. My targets right now are in this sort of initialization status, so they're being registered with the load balancer. That can initially take a minute or two. And let's see if I refresh this. They're still being checked. You can see the description. So there's a configuration for my web servers. And I mentioned in the lecture that you can enable something called sticky sessions. And here's that configuration option. It's called stickiness, and you can edit attributes and change enable stickiness so you could have sticky sessions. That's not something we want to do here. If I click on the health checks tab, then you can see the health checks that are being performed there. Click back on targets, and now my registered targets are considered healthy. So you see the status of both targets are healthy. Okay, let's open up another browser tab, and we're going to browse to that Elastic Load Balancer endpoint address. I do that, and you see that it will immediately route me to one of those web servers. In this case, it's an instance starting with the identifier 02cc. If I hit refresh a couple times, then it will route me to the other instance. Now you see the instance ID has changed, 04BA. So if I just click on refresh, you see that it's round robin. It's a sort of, it's in this case, I think it's a least used sort of load balancing scheme. And it's going to distribute each request that I make. It's distributing it to a different web server. Very, very simple, very straightforward, but really powerful. If I needed to support hundreds, thousands, millions of requests, then what I would do is just simply add additional web servers. Instead of 2 web servers, I could have 20, or I could have 200, and the Elastic Load Balancing service would redirect my requests to an available EC2 instance. Okay, let's go and simulate the failure of an EC2 instance. Both of these EC2 instances are currently healthy, and let's change that. I'll go back to the instances dashboard, and I'm going to select one of the instances, maybe the second one here. It doesn't matter which one you select. This one starts with an ID of 04BA. Let's go ahead and I'm going to change the instance state to terminate. I'm going to go ahead and blow this instance away. So it is now terminating that instance. And if I go to, well, let's go to the ELB and just click on request. And you notice that if I hit refresh, it's just sending me to the 02 instance. And if I click on the target groups monitoring, you see that there's only one healthy instance. Now, there's something kind of magical going on behind the scenes here, which I haven't really described yet. I talked about this health check, and you may have noticed that it was able to figure out very, very quickly that the instance wasn't available. And the reason was because I terminated the instance. And when I terminate the instance like that, it basically sort of sends a message to the load balancer, which says that, hey, this server is really going away because the customer is terminating the EC2 instance. And so don't bother to send requests to it. Another option, and what would be a good way to test the service would be to actually shell into the server, and instead of terminating the server, just shut down the Apache web service. Just stop that service so that the web server is no longer responding. The EC2 instance is still up and running, but the web server isn't responsive. And in that case, the health checks will come into play, and you'll see that the load balancer will take 50 to 60 seconds before it recognizes that the EC2 instance is actually unhealthy. But in this case, we remove the instance altogether, and that sent a signal to the ELB telling it that the instance was going away completely, and so it could be removed as a registered target. But you can see, like, I can change the topology of my application architecture. In other words, I can remove resources from that architecture without impacting the customer experience. The customer is making a request to the web server is still going to be directed to a responsive web server. And we'll look at how you can combine this functionality with other services like auto scaling groups in the future to dynamically add and remove capacity depending on customer demand. And that's where this service becomes really powerful. I hope you enjoyed this hands-on segment and you were able to learn how to configure and work with an elastic load balancer.